Welcome, everyone. Exactly 1 year ago, Chiara and I asked ourselves the question, can we build a tracker so tiny and fancy, yet so functional, that even a super agent like James Bond would be proud to use it or to wear it on him? So for this year's conference, we have tackled an entirely new mission. Today, we will show you not only how you will reduce the total cost of ownership of your assets, but also how to reduce the total cost of ownership of the IoT initiative itself. When I think about the IoT ecosystem, somehow an image of this rock comes to my mind. The IoT ecosystem can seem very confusing, a lot of bits and pieces, almost like a maze. Everything seems to be related, but also at the same time, it doesn't really seem to fit together properly. Now, the problem is, if we cannot get order in this chaos, we will not be able to successfully scale our project, and we will get stuck in pilot projects. And the last thing that we want to end up like is like sad IoT Cat. What happened to sad IoT Cat is that it installed a beautiful pilot, but after the pilot, it received a large amount of unexpected costs and bills, and because of that, IoT Cat had to cancel the whole project. The good news is, today we will show you how sad IoT Cat moved from sad IoT Cat to happy, and most importantly, very successful and rich IoT Cat.
So the goal of the next 10 to 15 minutes is to take you on this journey with us through these different steps that we took to optimize the total cost of ownership for our customers and to improve their ROI. So to briefly recap what Lily said earlier, last year we showed our James Bond-worthy tracker named by the tag S. And to give you a few specifications on what we did, here, full visibility that we provide to our customers on the positions. So we have different geolocation techniques that we use, Wi-Fi, GNSS, LoRa TDOA, BLE scanning, to provide seamless indoor-outdoor location. Then the tracker is, of course, optimized for battery life to make it last as long as possible, based on optimized firmware, and also using an accelerometer that can induce motion, or based on motion location fixes. Then, as you can see, it's very tiny, so it can fit on any asset. That was what we strived for, what our ambition was, to make it as tiny as possible to unlock even more asset tracking use cases. It is highly customizable in terms of settings. It can be perfectly adjusted to every use case in terms of location frequency, how often you want to have a position, and the different thresholds for the sensitivity. And then, all in all, it is an end-to-end solution. So we wanted to make it work with any system. On one hand, with our own system, of course, but then also easily integrate with our customers' APIs and their very own systems. So that's, in brief, what we are talking about today, which we took to the next level in the past year. So essentially, we went down this road of TCO, which we have seen a couple of times today, I assume. So next to optimizing the product itself, we spend a lot of time with our customers on optimizing all those costs that are associated with the network, the hardware, the maintenance, the infrastructure, the software, and energy, to cut it all down to a minimum and make sure that their ROI is optimized.
ROI. So naturally, when we start any kind of project, or specifically IoT project, we will have to commit to doing an investment, and sooner or later, we will expect a return of investment. If we don't, well, then our business case failed. An important way to control or to keep under control your return of investment is to keep under control your total cost of ownership. And the total cost of ownership, TCO, is nothing else but the sum of all the non-recurring costs, so the so-called CAPEX, together with all the recurring costs, the so-called OPEX. So for a typical IoT project, the CAPEX would of course, consist of initial licensing, but mostly one-time purchases, hardware, infrastructure, and then the associated deployment and installation efforts. The OpEx, which are feared a lot as well, are all the recurring costs, the energy costs, the network, data and cloud billing plans, but mostly dreaded again, the maintenance. So, as we all know, since we are all IoT ecosystem people, you will never be able to set your TCO to 0. And something that we have learned in the past years is that it's really important to find the proper balance between the CapEx and the OpEx. A simple rule of thumb that we like to give to you here is when you do your device forecasting, the higher the amount of devices that you are looking to put in the field, in the end effect, the more weight you should put into this CapEx kind of scale. Because the more CapEx you invest, the more tailored you're going to be towards your specific application, and you're going to be as lean as possible. An example, you might buy an off-the-shelf sensor or tracker that sends way too much redundant data that you don't need. Later, that means you're draining your battery. You will have to invest in maintenance much earlier. And of course, you also have higher OpEx in terms of data billing plans.
So let's start the journey of our 5 steps. Step 1, conceptualization, the most important part of the whole project, in my opinion. So first of all, we need to identify the business problem. Of course, it is very straightforward to say, hey, I need tracking, I want to see all my assets, I want to know in every minute of the day where it is, and it should work on the whole globe, ideally. So we are facing customers that have really a lot of expectations of what such a tracking solution should deliver. And then we start with discussing, okay, hey, what is the business problem? What do you really want to solve? Is it really that you want to have a location indoor and outdoor and on the sea and everywhere? Or is it just that you want to know, okay, the asset has now entered the warehouse, I can now take it on in my process, I can trigger an action in my ERP system, and thereof take on the journey. So sometimes those critical points are just the only thing that they want to know. So it's really important to boil it down to the business problem, and then from there start to design what we want to know. And then in the second step, we want to define the success criteria. In order to measure the ROI that we can achieve, we first need to know what are we going to measure. So this is also a very crucial part before starting the pilot.
And then, of course, we move over to the fun part, or at least for us, as a design house, this is the fun part. The heart of every project is the technical planning. Now, we have spent a lot of years doing technology-driven decisions, but I cannot enforce more and more that you need to be able to understand your business problem and define your success criteria. Your technical planning will involve all the technical decisions, which hardware, which wireless technologies, and it needs to be based exactly on that measurable goals that you want to achieve. Now, also, I would like to enforce here that the technical planning is the playground where you can play around with proof of technologies or proof of concept. That should be done before the pilot phase. And another last but not least important part of the technical planning, which might not sound so technical, is to plan the social setting. In many projects, we have seen that there are gatekeepers, maybe authorities, which actually define whether the project can be a success or whether not. It's really important to do that during the technical planning to ensure that your IoT project will scale over just the pilot. Now, when you start to install the pilot, as I mentioned before, we don't want, after the technical planning, we shouldn't be proving anymore that we can build it. We should prove why we built it and that it can fulfill exactly that success criteria that we defined before. So we want a proof of value. And then, if the pilot was done properly, and the proper pilot should be like a mini rollout, a mini version of the actual deployment, if that was done properly, then you shouldn't have any nightmares during the scaling. We would like to start here with having a look at the end devices, because the end devices in the end is what you're interested in. It's the device that will give you the valuable information to process. And it's really important to understand when it comes to hardware, it's much more than just plugging in an Arduino together with an ESP32. For a hardware to scale, we need to ensure that design, production, quality, installation, and maintenance are considered from the very beginning of the design phase. For example, production. If you do not design towards production, you will explode your production time, maybe not even be able to source your materials, and you will fail. Another point, quality. What is a worse nightmare than receiving a full batch of damaged or low-quality goods? The worst nightmare I had so far in my time of observing production is to receive a batch with non-uniform quality. A lot of good, but a few bad ones. That means that traditional sample checking doesn't work anymore for IoT. What we need is consistent checking of every functionality of every single device. And that again needs that we have to incorporate that in our design process to minimize the production time, again, to minimize the capex that you will be paying to buy our hardware. Regarding the installation, what we learned the most in the field is that fancy mounting option might look fancy. What we need is practical and easy to handle. Last but not least, maintenance. Maintenance means that we have to reduce the maintenance cycles, that we have to come up with efficient energy sources, maybe even multiple energy sources. And it also means that we should give as much as possible remote management features. So the next point is, usually we are mostly interested in the end devices, and the infrastructure is a bit invisible. Vinke and Johan have already shown a pretty nice example in their opening keynote. So when it comes to infrastructure, again, you will struggle with CAPEX and OPEX. And in most of the cases, you as an end customer will see only the OPEX. That means the building models and the quality of service, monitoring and maintenance, and fleet management. And we've seen a really beautiful example this morning. They incorporated all in one device, and I don't have to explain more, you all heard it. That's the way it should be done.
Then moving on to network and data management, a lot of different components to think of there too. First of all, network selection. For an asset tracking project, we want to make sure that we have network coverage where our assets are, or where we want them to be. So we want to make sure that we have exactly those locations covered that we need, and not overpay for too many locations and paying for global roaming, for example. So that's the first step to consider. Second step, security and encryption, of course, a very important aspect of the whole solution. Also, we want to make sure that our solution integrates security and identity management systems to make it a very safe system. Cloud hosting, there are also a lot of different things to consider. Do you want to have an on-premise solution? Do you want it hosted? If you have it hosted, do you want to have a pay-as-you-go subscription model, or do you have a fixed subscription model? All these components you have to think about to make sure that you don't overpay for what you're not using at all, but you also want to have the system scaling very easily with your demands. Also, in terms of data privacy, if you want to have certain data on-premise or another part in the cloud, if you have a hybrid approach, those are all the considerations you need to make. Data transmission optimization is a tricky one, because on one hand, you want to optimize the device itself for the battery life consumption, so you don't want to send too much data to the cloud all the time and do a lot of computations on the device, because it will cost a lot of battery. But at the same time, you also don't want to transmit too much positions and data at all, because then it's going to cost you a lot of network costs for all the uplinks that you're going to send. So there you really need to find a balance in what's really necessary, what kind of filtering techniques you can already do on the device itself, and what you will do in the cloud. Interoperability, also a very important topic. You don't want to have any custom or large custom developments for your own system. You want to have it integrated easily in your own systems. So also one thing to think about. Network management, I already spoke about it with the selection. It's a very important part that you make sure that you have the system that scales with your needs. Bandwidth control, also there, it's in the design of the messages. Do you send a lot of smaller messages or more longer messages? It's really how you want to scale your network that you need to think of the bandwidth. And for the last one, the data processing, I already talked about it before. Either you do the processing on the device or you do advanced processing then in your solution, where you take the messages as soon as they arrive and really just use the ones that you need so you don't spend too much on storage costs. Then we move on to the last step of our 5-step journey that we took on today, which is in the end the full stack solution. So I already mentioned it before. The data processing should be included. You want to have a zero-touch commissioning process. You don't want to touch every device, need to commission it on your system. This should all be done in one solution. You want to have the visualization inside and also have analytics, third-party integrations, and of course, the system needs to be very easy to use for your team, for all the people in the field that are going to look at the data, so also to reduce the training costs. So now we look back to the road that I showed initially. That's the solution that we provide at Truvami. We have worked on all those different components to make the TCO as low as possible for our customers. We have our hardware is built on a very modular platform, so we can easily customize for features, including temperature sensor or an accelerometer or a tilt sensor. So it's very easy to customize. We have the full stack solution ready to go. And our products are optimized for low power, as I mentioned initially. We have optimized the connectivity costs and different APIs ready for our customers, so it can be easily integrated into their system. So to close our keynote here, I would say mission completed. By leveraging this end-to-end solution, we can tag almost any asset that you want to have with a very easy solution right out of the box. We ensure that you have a seamless integration. We already reduced a lot of the complexity for you. Also, we have a great support system, but as our system is really easy, it's barely used. Of course, different integration options, and with that, with the end-to-end solution, also our customers have less compatibility issues. So if we are interested in learning more about our Truvami solution and also how we did it together with Miromiko, then please head over to our booth at A2, and we're happy to show you there more of our products, also one of our revolutionary smart labels that you might have seen before, and I'm happy to give you a demo there. Thank you.
Thank you.